Hello friends, today's question. A monoatomic ideal gas initially at temperature T1 is enclosed in a cylinder fitted with a frictionless piston. The gas is allowed to expand adiabatically to a temperature T2 by releasing the piston suddenly. If L1 and L2 are the length of the gas column before and after the expansion respectively, then the ratio of T1 upon T2 is given as. So we have to find out the relationship between T1 and T2 and respective lengths of the you can say gas columns before and after the expansion. And it is given that the gas expands adiabatically. So we are going to start from this only. We are going to use the expression for adiabatic expansion and then we are going to move forward. So we can say adiabatic expansion, we have two relationship. First one is give us P V raised to power gamma is equal to constant. Here P is pressure, V is volume, and the gamma is our adiabatic ratio or adiabatic index. Which is given as Cp by Cv, and this value is equal to 5 by 3 for monoatomic gas. For monoatomic gas. And the second relationship which we are going to use is our T temperature multiplied by volume raised to power gamma minus 1 is equal to constant. And here T is our temperature. So we can write the relationship for temperature T1 and temperature T2, corresponding volume V1 and corresponding volume V2. So let us call this as equation number 1. So you can say using equation 1 for temperature T1 comma volume V1 and temperature T2 comma volume V2, we get T1 upon T2 is equal to V2 upon V1, and we get this as gamma minus 1. Let us call this equation number 2. Next we are going to find out, or we can say we are going to write the relationship between the volume and the length. Relation between volume and length. So volume is proportional to the length of the gas column. Volume is proportional to length of gas column, or we can say V is directly proportional to L. Now we have two lengths L1 and L2, so we are going to modify this equation accordingly. Therefore we can write that V1 is directly proportional to L1 and V2 is directly proportional to L2, and if we write the ratio of V2 upon V1, that will be equal to L2 upon L1. We have this as L2 upon L1. Let us call this as equation number 3. So we are going to use equation 2 and 3 and find out the answer. Using equation 2 and 3, we get T1 upon T2 is equal to L2 upon L1 gamma minus 1, and value of gamma we already know is 5/3. So we substitute it here, we get L2 by L1, and this is 5/3 minus 1, which gives us the L2 upon L1 is equal to 2/3. So we got the relationship between temperature T1, T2 and length of the expanded gas columns. This is our 2/3. So if we check the options that are given to us, we can say the option number D is the correct option. Say option D is correct. Option D is correct. So this completes the question. Thank you.